Good morning to the 9 a.m. class. Just a little update. It's Tuesday, October 5th, and hopefully your Unit 1 review has been turned in, your Unit 1 project. And I'm going to be starting to look over those this week little by little, but I want to keep up with the current worksheets too. So I'll probably be starting with the 2.1 worksheets and then sprinkling in some projects and reviews as I go. I'll have all the projects and reviews done by the time we start reviewing for Unit 2. Don't worry, because the midterm is going to be all about Unit 1 and Unit 2 together. And I will also be sending out some information about the midterm in the next week. So we are finishing up lesson 2-3 today, and then we're going to start 2-4. So I'm kind of trying to get a little ahead, but kind of keep moving as we go here. So if everybody wants to turn to page 161, and I'm going to share my screen. According to taxifinder.com, which nobody probably ever really takes a taxi because we have Uber, from the airport in Las Vegas will cost you an initial charge of $5.10 plus $2.60 per mile. Use this information to fill in the rest of the table describing the total cost for various distances. Then create a scattergram using the distance as X coordinate and the cost as Y coordinate. So let's fill in 3, 4, and 5. And then actually, I'd like us to go to Desmos. We'll do a few here, but we're going to kind of see it on Desmos as well. Okay, so let's go ahead and share my screen again, my paper. So if we filled in these 3 costs here, let's see, what would we have? So for 3 miles, it would be $12.90. And then I have for 4 miles, $15.50, and then $18.10. And then if we were to plot these, this is what it would look like on my paper. So at 0 miles, we have to pay $5.10, which is a little over halfway between 4 and 6. And at 1 mile, we had to pay $7.70, and so on and so forth. And then I connected them. Okay. So if we go to Desmos, and then answer question number 3, I'm going to share my Desmos screen here. So in Desmos, I'm going to put in those extra points here that I've got. $12.90. Did you get the same ones, Carter? $12.90,
Yeah.
$50, and $18.10.
Yep.
And then the magnifying glass right here, we'll plot the points, and there we go. Okay. So question 2 says, what do you notice about the pattern that the points on your scattergram are making? Use the observations about it to pattern to connect the points, drawing the graph. So what did you notice, Carter?
That the price increases by the same amount.
Yep, that's true. And if it's increasing by the same amount, what type of model or equation did we come up with for the gas?
A linear.
Yep, great job. So it looks like a straight line, and because you said it perfectly, because we're adding and increasing by the same amount, it's linear. So I'm going to go back to my paper for a minute because I don't want to give it all away. So okay, so in question 3 here says the point where the graph crosses the y-axis is called the y-intercept. And so if I go back and I plot these again here. 1 and 770. And 2 was, it was 1030. Okay, so the Y-intercept for us is this point right here where we're crossing the Y-axis. And it's always a whole coordinate point. So we have to write it as 0 and then the 5, 10. So the Y-intercept will always have a 0 as the X coordinate. And then what does that mean? So do you have you come up with anything yet? Carter, what do you think the Y-intercept tells us if we were to describe it as someone?
For number 3.
Mhm. Well, I really just want everybody to be explained what it tells us. So it's our, like I said, our X coordinate is always 0 for the Y-intercept. And it's our starting value. And then the X-intercept would be when we cross the X-axis. But if that were the case, that would be over here somewhere, right? But in this case, we cannot have negative miles that we travel. So we won't have an X-intercept on this one. But if we did, it would look like this. It would be an X value when Y is 0. Okay. And so number 4 says, how much more will you pay for a 3-mile ride than a 2-mile ride? So I'll let you work on these couple and we'll come back and check them together. So it looks like we got $2.60 for the 1 additional mile. And just a reminder, everybody, this is our lesson check. And I think I did not have units on there. So $2.60 should work. And then Carter came up with number 5 on the difference between 3 miles was $7.80. So let's go to page 162. And it asks us to pick any 2 points in the graph that you drew. So any of the points, we had 0 miles through 5 miles. And let's write them as coordinate points. And then it says, subtract the second coordinates. So these are the second ones on the right. Then divide the result by the difference of the first coordinates. Okay. So I'll let you pick 2 and I'll pick 2, Carter, and we'll see if we come up with the same thing. I'm picking point 1 and 4. So 1 mile and 4 miles. What points did you pick? So if I take the difference in the second coordinates, I'm gonna start with 770 and subtract 1550. And I get a negative 780. Then it says to take the 780 and divide by the difference of the first. So if I started with the 770, then I have to start with the x coordinate of that pair. So I have to start with 1 and subtract 4. So negative 780 divided by a negative 3. Well, that's good. I get a negative divided by negative because I was worried about getting a negative answer, but a negative divided by negative gives me a positive 260. And I'm going to keep my units. My units for X are miles. And then this is money. So that looks like my money is on top. So this is $2.60 for 1 mile. Did you get that as well?
Wait, so what do you divide it by?
It says take the difference of your second coordinates. So whatever your cost was, you're going to take the difference.
Mhm.
And then it says divide that difference by the difference of the first coordinates.
Oh, okay.
And for those at home, this is the formula of the slope of a line down here, and they use a couple of different ways to explain it. We usually give it the letter M because I mentioned on the Zoom before that a linear model is y equals mx plus b, or some outputs write it as y equals b plus mx. But you can write it in either order because the mx stays together either way. The m is our slope. It's if you're given in this format, you're always the slope is always being multiplied by the x. So we're taking the difference of the second coordinates divided by the difference of the first coordinates. Good morning, Stephen. Sometimes I just use the symbol delta x over delta y over delta x. Delta is a Greek symbol, but it actually means change or difference. So we're taking the change in the y's over the change in the x's. Did you get 260, Carter?
Yeah.
Oh, excellent. What did you use different points, I hope, than I did?
Yeah, I used 2 and 1030 and then 5 and 1810.
Awesome. So that kind of shows, right, what we thought when we said we were having a constant change. It doesn't matter if your change is constant, it doesn't matter what points you pick. And even we could even go, it's not even just single point to point. We could go this point to this point, right? It doesn't have to be just 1 to 1. That ratio should always be the same if it's linear. So let's look at number 7 here. It says, if you were to connect the points 170 and 510 on the graph in question 1 with a triangle, it would look something like this. Label the coordinates of the 2 given points on this triangle. So label which one you think would be 1 and 770 and the other is 5 and 1810. Did everybody draw theirs? So I had 1 and 770 right here. And I had my 5 and 1810 right here. Excuse me. And then number 8 says, how much more distance was added to the ride going from 1,770 to 5,1810? Label this value on the triangle. Anybody get that yet?
4 miles.
What was it?
4 miles.
4 miles. Yep. So we went a distance of 4 miles because this would be 1 and this would be the 5. Okay. And then on the top of page 163, it says how much cost was added to the ride between those 2 points, and label that on the triangle. So now we're talking these two values. So this would be the 770 and this would be the 1810. Anybody get the difference in cost?
1040.
That's what I had too. So difference in cost was 1040. Did you get that too?
Yeah.
1040.
Yep.
Okay, excellent. Then 10 says, find the slope of the line using your answers to 8 and 9. So this is our change in Y, right? This 1040. So slope is the change in Y, which is the 1040 over the change in X, which we said was 4 from the previous page. What we get there? Excuse me. And we divided that.
I 2.6.
Yep. So we just got the same slope, right? So we can see that from the actual calculations of slope, like what we did up here, and then we can also see it in the graph. So 11 says, how much would 4 miles add to the cost of a taxi ride? Would it matter if the change was from 1 mile to 5 miles or if it was from 20 to 24? And I'll let you all answer that here in just a minute. I'm gonna pause. So for 11, what did y'all get for the 4 miles?
1040.
1040, okay. So does it matter if I'm traveling from 1 mile to 5 or 20 to 24?
No.
Okay, why doesn't it matter?
Because it's linear, so it goes up by the same no matter what the miles are.
Okay, so it's $2.60 per mile. No matter which miles, okay. And so our answer was $10.40. Okay. And then 12 says the thing that makes a line is the fact that the slope never changes. We know that. So how can we know if two quantities are modeled by a straight line? Carter mentioned at the beginning, there's constant addition between values. And visually, you will see a straight line. Okay, and then how do we estimate the distance we can travel with $16?
I did the 16 divided by 2.6.
You did 16 divided by 2.6?
Yeah,
Okay, let's see, what does that give us?
I got a 6.15, but that was rounded.
Okay. What about you, Maya, or Carter, what did you get?
So I did 16 minus like the zero distance, so like the fee, so $5.10.
Okay,
And I got, I'll do that right.
so you
Yeah,
so you took the $16 and subtracted the fee, right?
yeah, and I got 10.90.
Okay, so you got $10.90, but that doesn't tell us miles. So no, this is great. Stephen didn't take into account we had the $5.10 fee. So that's definitely over on miles because we do have to take into account for that. And then Carter got us to this. Both of them are useful. So this 1090 is how much we have left, right, to use on miles.
Oh, so would it just be 10.90 divided by 2.6?
Yep. So now we have the 1090 divided by the 2.6, and that will tell us how many miles we can actually go.
So like 4.2 miles.
Yep. So approximately 4.2 miles. Excellent. And you didn't even think about it, but we actually solved a linear equation there. Okay, I'm going to show you why. So, because so many students are fearful of equations and solving. So our equation was really $2.60 times the miles, X, right? Plus the $5.10 that we have to pay no matter what. So this is our Y-intercept. We said that the 510 and the 260 is our slope. And we want to find X so that if our Y is 16, this will equal out, right? So in steps, you guys did a great job just kind of thinking about what do I have to do? Well, you automatically have to cancel out that or subtract away that fee that you have to pay no matter what, right? So that's, you always have to get rid of the constants first. So we did that, and that gave us the 1090, and that's still equal to the $2.60 times the miles. And then because we were multiplying, we would divide to solve for X. And we got 4.2 miles. So you did some algebra, you didn't even think about it. Didn't even stress about it. Okay, so let's move on to the second. How about we take maybe a quick 5-minute break since it's almost 10? And then when you come back, we're going to get started on this next problem. It says everyone knows that after you buy a car, in most cases, its value decreases as it gets older. Suppose you bought a used car for $15,000 a few years ago, and its value has been decreasing at the rate of $2,000 per year since. Make sure you answer each of the remaining questions with a full sentence with punctuation and everything. So we're going to take our break, but when we come back, just to get everybody started, here's the graph. They gave us a table this time. So before they gave us a table and we used the values in the tables to find new points and to find the y-intercept and the slope from those coordinate points. But now we're going to use this table and the graph to answer some questions as we go. So I'm going to pause the recording and we can take a few-minute break. So 14 says, find the y-intercept of the graph and explain what it means. So the y-intercept is going to be where we cross the y-axis. So right about here. What did everybody get?
The y-intercept is 15,000, and it means that that's how much you bought the car for. Like it's your starting value.
Okay. And just a reminder to everyone that this is how we always write the y-intercept. It's a coordinate point. So the car value when we purchased it was 15,000. So make sure you're giving me full sentences with like who, what, when, and where. Then it says, find the slope of the line and explain what it means. So this is a little bit trickier. We could do a couple of different things, right? We could find it by hand between these 2 points. We could see that it looks like we're going down by 2,000 every 1 year. Right, so again, we're going down by 2,000 every 1 year. Everybody see that? So it looks like our change in Y is a negative $2,000 over 1 year. So we could say the car decreases in value by $2,000 each year. Excuse me. So notice I didn't say the word negative. I used the word decreases to describe the negative. And I talked about what, which was the car and the value of the car, what was happening with it. And then I made sure I said each year. So give me all of your units for that. So did anybody estimate the value of the car after 42 months?
Yeah, I got 8,000 for the value.
Okay, how did you get that?
I did y equals negative 2,000 times 3.5 in parentheses because 42 months is 3.5 years. And then I did plus 15,000.
Okay, so say it again now. So you said you had y equals a negative 2,000 x.
Yeah. Yep. And for the x, it would be 3.5.
And how did you get 3.5?
Because it's 42 months, and since the car decreases in value by years, you just take 42 and divide it by 12.
Okay, so 42 months divided by 12 months will give me years. So that comes out to be 3.5 years. Okay, so that's going to be x.
Yeah.
So this is 3.5. And then you said plus 15,000?
Yeah.
Okay. Excuse me. So what we did was we took our y-intercept that we had up here, and that is equal to B in our equation, Y equals MX plus B. Just a little side note, M and B are the parameters. M and B are the parameters, which means that once you find them for your scenario, they don't change. Kind of like a recipe, right? Once you know certain ingredients and how much for a recipe, they don't change. Okay, so, and then Stephen put those together, multiplied 3.5 years times a negative 2,000 plus the 15,000, and he found out that the value after 3.5 years would be $8,000. Carter, did you agree with that? And what about 17? It says estimate the number of years it took for the car to reach a value of 6,000.
So I just used kind of the same formula. I did instead of Y, it was 6,000 equals negative 2,000 X, because we don't know the years, and then plus 15,000.
Okay, so you said 6,000. Okay. So, yep, so we could kind of do what we did on the other side, right? We could subtract both sides by the 15,000. Which feels weird because we get a negative 9,000. But because we're going to divide both sides by a negative 2,000, the negative divided by negative gives us a positive number of years, and we need to make sure that that's positive. And 9,000 divided by 2,000 is 4.5 years. And I am going to show on Desmos how we can do this, because we're going to be building on this 18 and 19. I'm going to summarize real quick. I'll let you guys summarize that real quick, and I'm going to get my data into Desmos here from this table. So we'll come back to that here in just a minute. And I'm going to do a new share. So you can see my Desmos here. Okay, can everybody see my Desmos table that I created?
Yeah.
Okay, I'm going to do my magnifying glass. There's my data. We can see the same graph that they gave us. Now, because I think it's linear, I want to confirm what I think the slope and the y-intercept are. I'm going to, here on number 2, right here in this line, I'm going to type y1. I want to predict y1. So when I'm predicting with data, I have to use this little tilde squiggly, which is to the left of your 1 key. So shift in that key gives me the tilde. Or you can down here on the bottom left here, you can go to the keyboard, and you can bring up the keyboard, and that symbol is on the keyboard, I believe. Maybe not. I think you just have to type it with your shift. Oh, right here it is. If you do on the keyboard, if you go to the ABC button, then when it brings up the alphabet, it's down here at the bottom. But if you just use your shift key and the key to the left of your number 1, that will also bring up the tilde. I'm going to hide that. Okay. And then I'm going to tell it I want it to be the MX plus B. So I'm going to say M X, but I wanted to use X1 because I wanted to use the table, the X1 numbers to predict the Y1 numbers. And then I have to say plus B. And it confirmed what I thought. M is a negative 2,000, B is 15,000. And because this is a perfect linear equation, the R squared is 1. And we're going to talk about the R squared in the next couple of lessons, so don't fret, but I just want to make sure everybody's starting to see this. We're going to use this in the unit 1, the unit 2 project. Okay. So what did we, for 18 and 19, what things can we describe for the slope and the y-intercept?
To find slope, you start by subtracting 2 y coordinates and dividing them by 2 subtracting x coordinates, y2 and y1 minus x2 over x1 or minus x1.
And so because we're dividing 2 different rates or 2 different units, it's called the rate of change. Excellent. And then 19, how do we find the y-intercept?
I don't know if this was too just like obvious of an answer, but I just said that you look for the point that's on the y-axis.
Okay, yep. It's the y value when the x value is 0. And we're looking for where the line crosses the y-axis. So yeah, so there's a couple different ways that we can describe that. Excellent. Excellent. So we are going to look at 2-4. So we're going to move to page 171. Okay, hopefully everybody's back for 2-4. So 2-4, our title is called The Effects of Alcohol, which we are going to do an example with alcohol later on in the lesson. But right now, we're going to kind of take this idea that we learned in 2-3. We learned how to calculate the y-intercept. We learned how to calculate the slope from 2 coordinate points, but we also learned from visually in the graph. I showed you a little bit about modeling in Desmos. And so now we're going to kind of see it from a different point of view and build on it. So it says a student org you're involved in is planning a year-ending pizza party to celebrate another successful year on campus. As chair of the planning committee, you've wisely worked to deal with a local pizza place to provide large pizzas at $9 each. The budget will allow at most $175 to cover the food. And of course, you'd like to know how many pizzas you can get and stay under budget. We'll attack the problem in several different ways. So I'm going to let you start working on 1 and 2, and then we'll kind of resume and answer some questions. You said 19? And where did you get 19 pizzas?
I did 175 divided by 9.
Okay. And this is $9 per pizza, right? So it's a unit exchange, even though it might not feel like it is. So you said it, but it comes out to be 19 point what?
It's 19.44, but I dropped the repeating
Right.
4 because
We can't have part of a pizza. Well, now some pizza places you can go and buy part of a pizza, but not all. So we can do that. So just a minute, Zaria. So it says write an equation that represents the total cost C of ordering P pizzas. So did we come up with one?
I did a C equals 9P plus 175.
Oh, plus 175.
Oh, is that?
So plus 175 means. So if we did this question.
Oh, yeah, I guess.
That would mean we are starting with a cost of 175, right? So I don't think we want that. I think we just want the cost, which we're trying to keep to amount of 175, right? But in general, this would work. So let's say we bought the 19 pizzas, 19 times 9. Excuse me. Excuse me. If we bought 19 pizzas, that would be $171. So that would be our cost. But we're trying to hold our cost C to 175 because that's all they've allowed us. So let's go ahead and go use that equation that the cost is equal to 9p, so $9 per pizza, and fill in your table here, and then your graph on number 4. And or put your data into, instead of a graph on paper on 4, go ahead and put it into Desmos. So I am going to go to my Desmos screen and put in my data that we talked about for the pizzas bought. So notice in my Desmos, I have that modeling thing that I had before. So if you always kind of have that available in your Desmos, it's going to be set up. Then I'm going to go up to the plus and I'm going to say add a table. And I'm going to make my table X1 again, and whoops, X1 and Y, Y1. Okay. And I'm going to put 0, 5, 10, and my table is going by 5. So we got to 30. And then we have to fill in our table. So what did we get? For the table, filling the table in. So if I buy 0 pizzas, how much is my cost?
0.
0. That I like that one. What about 5 pizzas?
45.
Okay. And what about 10 pizza? Oh no. 10 pizzas.
90.
Okay, there we go. Okay, and 15 pizzas.
135.
Okay, 135, and then 20.
180.
180, okay. And then
225.
225. Okay. And then
270.
270. Okay. And then notice, as soon as I filled in my table, it went ahead and gave us the equation up here. It's so awesome, isn't it? So it validated what we said. Slope is 9. And so we did it correctly. And then I'm going to go ahead and hit my magnifying glass to practice this as much as possible. And you might be wondering, like, well, why are these connected? Because we did this modeling. Notice that the model up here, the little circles in black. So it's saying we're going to do the model and then we're going to draw a line through the model, and ours fits perfectly because it's a perfect linear fit. Not all of our data will be perfect. So starting in 2.5, it's going to become imperfect, but close to perfect. And we're going to just see how perfect it is. So can we move down to question 5, where it says, since we want to spend at most 175, this is a good place to use an inequality. Write an inequality. So I'm going to go back to my paper here. And let's see, once it's to write an inequality. So we did have this, right? So it says write an inequality that can be used to find the number of pizzas you can buy for at most 175. So let's talk about at most. At most, another way you can say at most is not more than. Does anybody have another way to say at most? Another way to think about it for folks at home?
Less than or equal to.
Okay, less than or equal to, yep. So the cost So really, we want the cost to be greater than or equal to, well, in our case, we don't want it to be more than 175. So we want 175 to be greater than or equal to the 9p, right? We want our number of pizzas to be times 9. It has to be under. So we can really write it like the cost, which is 9p, has to be less than or equal to 175. So the cost, which we know equals 9p, this has to be less than or equal to 175. It says then solve that inequality and use the result to decide on the number of pizzas. So I'm going to do this sheet of paper here. So if we said 9p has to be less than or equal to 175, and because we're multiplying here, we're going to divide by 9 to undo the multiplication. So the number of pizzas has to be less than or equal to the 19.4 or whatever you had. Is that right, Stephen?
19.4 repeating.
Yep. And we can't have part of a pizza, so we said that p has to be less than or equal to 19 pizzas. Okay. Any questions? Now, it says, what is the slope of the line you drew in question 4 and what does it represent? What did we say the slope was?
The slope is 45 over 5.
Okay. And so if we go back to our Desmos, we saw that our slope came out to be 9, right? 45 divided by 5 is 9.
Yeah.
So $9 per pizza. It's a unit rate. And so it represents that each pizza costs $9. And then it says, what is the y-intercept of the line and what does it represent? And so we can see here from our graph, I'm circling, and then in our table, I'm highlighting.
Y-intercept is 0, and means you haven't bought any pizzas yet.
Right. Or if you don't purchase any pizzas, you don't have any costs, right? In the sentence form there. So I'm going to go back to my paper. So if you, I'm just going to, it'll sound silly, but I'm going to write it like we would. So if you buy 0 pizzas, then you have 0 cost, but you have no pizzas. So it says, nice job so far, but did we forget to mention the $10 delivery fee? Darn it. Sorry, you'll have to rework the problem, keeping in mind that we want to know how many pieces we can get for at most $175 at $9 each, plus the flat fee of $10 for delivery. So it says, write an equation that describes the cost C of buying P pizzas with the delivery charge included. Okay. So let's think about this one.
Would it be like what we had before, but just adding the plus 10, like with the 175 or without it?
Well, without the 175, that's just, we're using the 175 when we have a particular situation we're trying to work around. But in general, we're saying the cost is $9 per pizza plus $10 delivery fee. So I
Okay.
agree with you. Yep. So now if we go to complete our table, at 0 pizzas bought, it's no longer 0, right?
Well, no, would it still be 0? Because if you didn't buy any,
Right, but
there's no delivery.
true, but we're gonna pretend like there's a fee. Right, until we start buying, there's no fee, but
Okay,
we're gonna pretend that there is that $10 fee. They're not gonna actually physically charge us that, we know that, but we're gonna use it as part of our calculation. So if we buy 5 pizzas, it was 45, but now it's 55 because of the delivery fee, right? And when we bought 10 pizzas, it was 90, but now it's 100 because of the delivery fee. And then is this 145? $90 to 35 and 280. Is everybody in agreement with those?
Yeah.
And then I'm gonna go to my Desmos so everybody can see in Desmos. And you can see here, my black is my black line and my red are the red dots. So, and it looks like everything was just, how does that compare, my red to my black?
it's just up 10.
Okay, so it looks like it was just shifted up 10, right? The $10 delivery fee. Okay. And so I'm going to do a model for that one too. So let's go here and actually let's just type, I want you to see what it looks like when you just type in an equation. So if I were to type in an equation that we think is going to go through those red points, I'm going to use an equal sign, and I'm not going to use my X2 and Y, my X1 and Y2, because I'm not using real data. I'm saying I'm going to tell it an equation. So Y equals, and we think our equation is 9P or 9X plus 10. And so now notice over here in Desmos, it tells you what color that line is. It's green, and it goes through all the red points. So that says that what we thought about red, that equation is, we came up with a red equation for the the cost of the pizzas plus the $10 delivery fee. What's cool when you go on these lines here, even the black one, notice I'm on the black line and I'm with my pointer on my mouse, my left button down, I'm moving up and down, and you can just move it where you want it. It's pretty cool. And you can do the same on the green. And I want to show you, well, actually, let's flip the page in our course pack here. Number 11 says, write and solve an inequality that can be used to find the number of pizzas you can buy with the delivery charge added. So our limitation is still the $175, right? Well, I'm going to show you something on Desmos. You can actually just grab on the green. So let's grab on the black first thing. Let's go to 175. So I'm going to go to where my output, my second number is at 175, because that's where we want to stay within. So we said right here at 19 pizzas, we would be just under the 175. Now I'm going to go on the green, and I'm going to try to do the same thing. I'm going to try to stay under 175. Oh, 18.4 pieces just went over 175. And it looks like at 18.3, so we'd have to go down to 18 pizzas to be under the 175. Because that delivery fee, right? Another way you can do it is in Desmos, if you're there, if you go down here to another line to type something, I'm going to say, let's draw me a line at Y equals 175. And now when it enter, and now when it did, look at it, gives an intersection, I can just click on that intersection and it will tell me when it intersects 175, the number of pizzas, and it'll tell me this one where it intersects the 175. So there's some really cool things we can do here in Desmos. I'm gonna go back to my paper so we can fill this in. So we said 18 pizzas. So on 12, it says, what was the slope we drew on this one? It was still, M was still $9 a pizza. And then this time, our y-intercept did change, right? Our y-intercept is not just 10, but we always have to write it as a coordinate point, 0, 10. And what does it represent? There is a fee of $10 that we start with before we even order any pizzas. So now number 14 says, now here's the key idea. Look back at your answers to questions 8, 12, and 13. The slope was blank, the y-intercept was blank, and the equation was blank. Anybody have them? What were 8, 12, and 13?
So the slope is 9. The y-intercept is 0, 10.
Mm.
And the equation is C9 plus, or 9p plus 10.
Okay, 9p plus 10. Excellent. And so 15 says, a small business had just 12 employees when they opened their doors, but they had been adding employees at the rate of 4 per month since then. Write a linear equation that describes the number of employees in terms of the number of months after the company was founded. So let's define our X and Y. So X is, we're basing it per month, right? So X is going to be months. And Y is number of employees. Also, they gave us some good definitions up here. It'd be good to read through. So when we write our equation of a line, which is important here in the purple, the y equals mx plus b, the m, the slope, is always what we call the coefficient. Co meaning with. So the x goes with the slope. And then our y-intercept is always the constant, a constant, which is something that's always there. So like if you have a delivery fee or a monthly charge to be part of something, right? Kind of like a Wi-Fi or whatever, you have a monthly fee, and then if you go over on your usage, you have more. But that that fee that stays all the time is your constant term at your y-intercept. So let's see if we can write an equation with this scenario here. 15, 16, and 17. And then that ends this part of the lesson. Anybody come up with an equation they think will work?
I have y equals 4x plus 12.
Y equals 4x plus 12. So we think that 12 is our y-intercept, right? I would agree with that because we started with 12 employees. And then it says we are adding employees at the rate of 4 per month. So I think that would be correct. Okay. And it says, what are the slope and y-intercept, which we just said them, and what do they tell us? So they show us that the company's growing, right? And we started with 12. And we know how to graph and all that stuff. It is important to understand what needs to be on there. So our months would go on the bottom, and our number of employees would go over here on the vertical axis. And we have to make sure that they start at 0. But again, we would, because we know the equation, we could just go and put that equation into Desmos. And I'm going to delete these because we've already done them. But we could just put this equation in. So y equals, we don't do the tilde, we only do the tilde when we have coordinate points. So 4x plus 12. And then there's the line that we drew, and that makes sense. And the cool thing is when you put in an equation, you can go up here, see this gear, it says edit list. And then this comes up and you can say, create a table of some points for my equation and see if it makes sense. And it did. So we don't really need -2 and 1, but if we have one month, we've got our initial 12 employees and we added 4, and then we added 4, and you can put in any number you want here. What about after 1 year, 12 months, we should have a total of 60 employees. So that's how we can use Desmos on there. So are you boys okay moving on and doing a little bit into the next part of 2.4
I'm okay, yeah.
before we get going? Carter, you're okay with that?
Yep.
Okay. We've already got our lesson. Oh, I didn't do the lesson check. Oh, we got to get the lesson check. Lesson check is number 16. So I'm going to share my screen before we move on. Oops, I almost forgot. I'd like to tell everybody that. So our lesson check for 2.4 is number 16 here. It says, what are the slope and y-intercept? So the slope is equal to 4. And that's what the question is on the lesson check, just 4. And then the y-intercept is the 0, 12. So 2.4 is kind of a longer lesson just because we want to give you lots of different stories to kind of work around here. This is a good one, and we'll get started with it today and see where we end up. So it says, now we turn our attention to studying the effects of alcohol. Blood alcohol concentration is a percentage of alcohol in the bloodstream. The legal limit for operating a motor vehicle in most states is 0.08. This means that 0.08% of a person's blood is alcohol. So the table here is from WebMD and tells how a person is affected with different BAC levels. So may pass out, tremors, memory loss, cool body temperature at 0.3, slurred speech, poor coordination, slow thinking at 0.10. Okay. So, okay. So let's move on to 1. It says, after being arrested for driving under the influence, a well-known starlet was found to leave 3.5 times the legal limit of alcohol in her blood. What was her blood alcohol concentration? Okay, so it says she had 3.5. So 3.5 would be 3.5 times legal limit. And the legal limit is 0.08. right? No. Yeah, the legal limit is 0.08. So 3.5 times the 0.08. Is 0.28. And that says explain exactly what your answer to question 1 means. Blood, alcohol, concentration was 0.28%. And 0.28%, she was almost ready to pass out, right? She was within passing out, memory loss. Crazy. Describe some of the effects the arresting officers may have been able to observe. So she would be close to passing out. What else? So she's above the 0.2, very much above. So probably trouble walking, double vision, nausea. She might be vomiting. What did it say? Double vision. Okay, so it says John Q, bonehead, decides it would be a good idea to drive when he shouldn't. Fortunately, he gets pulled over before anything tragic happens, and a BAC test finds a level of 0.16 at 2 a.m. Unlike most other drugs, studies have shown that the alcohol leaves the bloodstream at a constant rate. The table shows his BAC after every hour after the arrest. So we can put this data into Desmos, and it's asking what is the slope, what does it tell us, and what is the Y-intercept? So I'm no longer expecting you to do anything by hand. I'm suggesting highly that we go to Desmos, create a table, and we put this data in. So we're going to at least get this in for the day before we leave, and then we can work on answering some of these questions here. Okay. So in my Desmos here, I'm going to put 0, 1, 2, 3, 4, just like they had, and then 0.95, 0.95. Okay, so we have this. I'm going to, you can see my dots, but not very well. So I'm going to hit my magnifying glass here. And you can see that it doesn't look like a perfect straight line, and it's not going to. Oh, and that's maybe because I typed in 0.15 and 0.16. There we go. It is a perfect straight line. Okay, we want to find the model. So we're going to, from now on, let Desmos do this when we have data. So to let Desmos do this, we have to use the whatever Y1 it has for us in Desmos. Mine has Y1. So I'm going to say Y1 and then tilde and then M for slope, whatever my Desmos has, which is X1 plus B for my Y-intercept. You can call M and B anything you want. I'm going to call them M and B because that's what we've been using. And I'm going to save this graph here. Oh, I'm going to go up here and no, I want to save my graph. It's not running. This is weird. Okay. Oh, because I'm not logged in. This is main. So go ahead and get yours in, and then I'm going to save it. Now I can save I'm going to save mine, it's gonna let me title it, so I'm gonna say lesson 2-4 alcohol. BAC. Okay. And then I'll put this link in the recording in JetNet so everybody has it. Okay, so you can see that my R squared, which we said we're going to use, is a 1. The R is what we really want to use. The R tells us if it's negative, it tells us that it is a negative slope, and you can see that in the graph. And the 1 tells us it's a perfect relationship for linear. And our parameters are M is negative 0.015 and B is 0.16. So let's write that on our paper. For number 4, M is negative 0.015. And number 5, the y-intercept is 0, comma 0.16. Okay, so let's go back to our paper and just write out what these mean. So we have them. So for our slope, it's for everybody should be following this description formally how to write this. So for every 1 increase in, and this is where we're going to put our X variable. We're going to describe it in, and our X variable is hours after 2 a.m. we can expect the BAC to, and now I'm not going to say negative, I'm going to say to decrease, and that shows the negative, to decrease by, and this is where we enter Y. I mean, this is where we enter our slope. And our slope is 0.015. And then 5 says, what is our y-intercept? And there it is. And it says, what does it tell us? It tells us that John started with a BAC of 0.16 when he was pulled over at 2 a.m. That's what we're starting with. So let's put it all together, the equation here. So it says, write the equation describing John's BAC. So we're writing this with our parameters. So M and B. So Y equals negative 0.015 X plus 0.16. So this is our model that we came up with. So number 7 says, when using an equation to model a situation, it's important to recall what specific information the equation provides. Restate your answer to question 6 in the form of a statement like this. If X represents blank, then Y equals blank represents blank. Says, don't physically fill in the blanks, write a full sentence. So if X represents hours after 2 a.m., then Y represents the BAC after X hours. Everybody with me so far? So let's answer 8, 9, and 10. So we can be done with this part. So it says we've learned about several features of graphing calculators. We've already basically done this in Desmos. We've been doing a lot in Desmos. 9 says, what would Mr. Bonehead's blood alcohol concentration be at 3:30 a.m.? Remember, eating greasy food won't change it. So at 3:30 a.m., we have to figure out how many hours after 2 a.m. that is. So 3:30 a.m. is 1.5 hours, right, after 2 a.m. So we're talking about x equaling 1.5. So we can go to our Desmos here and do a couple of different things. We could just grab for this one, because we have a model, we could just grab this and go to where x equals 1.5, and we're getting really close. And there it is, 0.1375. 0.1375. I'm going to show you another way that's easier. If you just go to another line in Desmos and type, I want to know, oh wait. Well, you could just type it, y, you could say your slope, which is negative 0.015 times 1.5 for the 1.5 hours, 1.5 parentheses, plus your y-intercept 0.16. That would be one way. Or you could, like I said, you could just go to your graph and drag it to 1.5. Sometimes it's hard to get right there to move your mouse just perfectly, but there we've got it. 0.1375 is the BLT or BAC, not the BLT, the blood alcohol content. Number 10 says, how many hours would it take for his BAC to drop below the legal limit of 0.08? So that's when Y is 0.08. It says, set up and solve an inequality to answer the equation. So I'm going to show you in Desmos. So in Desmos, we want the Y to equal 0.08. So I'm going to type that line, and then notice down here. So I have to bring up my graph. You can, when you're in the graph, if you press your left mouse key, you can drag your graph wherever you want it. And so I did it just so I can see it better here. And I can click on this intersection point. So I can go to that button and see that it's about 5.3 hours before he gets to that legal limit. So approximately 5.3 hours. Paper, I'm going to write approximately with not an equal sign, but this is an approximation. 5.33 hours to get below the legal limit of 0.08 BAC. Any questions on that one? And 11, 12, and 13 are all going over things that we've already done in Desmos. So you don't even have to worry about those because we've already drawn the graph and we've already used the graph to answer some questions, and we've already talked about the y-intercept. Oh, it says, what is the x-intercept and what does it mean? Ooh, the x-intercept, that's a good one. So the x-intercept would be the x time, right, when he doesn't have any alcohol in his blood. So that's a good question. So let's go back to, before we end, let's go ahead and go back to Desmos for a minute. And we can again force our y to equal 0. So when we do that, I am going to zoom. I'm going to go up here to the top right. I can zoom in and out. So I'm going to zoom out for a minute so I can get to the 0. And I'm going to click on that button here. And it looks like when I do that, he's not going to be back at no blood in his alcohol, or yeah, alcohol in his blood until 10.67 hours. So one last share here. So 10.667 hours until there is no alcohol in his blood. And questions 14, 15, and 16 are asking you to sketch an example with a positive slope. So that would be something here, a positive slope, right, going uphill. And then sketch an example of a line with a negative slope. So this would be a negative slope going downhill. And then it says, can you describe what a line with a slope of 0 would look like? Okay, a slope of 0 would, it has to be like kind of walking across the floor in your room, right? Unless it goes uphill. So it'd be something that just looks like this. So the last problems that I have listed on the schedule are page 183, problems 1 through 17. And it's just a really big extension problem that I'm not going to work on because we're going to continue to get practice on 2526, 2728. I will make an extra video that will be in my YouTube video set. That will be this problem 1 through 17 on page 183. So if you're interested in working on that and checking your answers, you can do so kind of on your own. So in class, we will then move to lesson 2.5.